Okay, so number 1, part F, negative 5, 6 raised to the negative 2 power. So we have to simplify it. So obviously we have a negative exponent. So to make that negative exponent positive, we're going to flip the fraction. But we're not going to change the sign of the fraction. So when we flip it, we get negative 6/5. That changes the exponent to a positive 2. Now we can apply the power property, 6 squared and 5 squared. But you have to be a little bit careful here, because when you square a number, you're multiplying it by itself, right? And a negative times a negative is a positive. So we really end up with positive 36 over 25 as our answer. So part E is negative 3/5 raised to the negative 2. Similar to the previous one, right? But the difference is the negative sign is outside of the parentheses. So now when we flip the fraction, we're going to keep this outside and we're going to flip it to 5/3. That becomes a positive 2 exponent. Now we apply the power property. 5 squared is 25, 3 squared is 9, but this is all happening just to the 5/3. The negative sign out in front, nothing is happening to that, so it remains, and our answer is negative 25/9. So part C, negative 4 raised to the negative 4th. No parentheses, and that's important because you need to think about this as negative 1 times 4 raised to the negative 4th. It's as if that negative sign is outside of a set of parentheses. So the negative 4 exponent is applying just to the 4. So bring this negative 1 along for the ride. Let's flip this to make it 1 over 4 now to the positive 4. And 4 raised to the 4th is 256. So we have negative 1 times 1 over 256, which ends up being negative 1 over 256. Okay, so this is number 2, part E. We have negative 35 x to the 7th over negative 7x squared, and it's all being raised to the 3rd power. I suggest simplifying what's in parentheses first. So negative 35 divided by negative 7 is positive 5. X to the 7th divided by x squared, that's the quotient property, x to the 5th. All of that is being cubed. Now we can apply the power property. So we take each thing in the parentheses and raise it to that power. So 5 cubed and x to the 15th because we multiply the exponents. 5 times 5 times 5 is 125, x to the 15th. All right, so 2f, 40 x to the negative 8th over negative 8x to the negative 2 raised to the negative 3rd power. So again, I suggest simplifying what's in parentheses. So 40 divided by negative 8 is negative 5. X to the negative 8th divided by x to the negative 2, that's the quotient property. We subtract the exponents. Subtracting a negative is the same as adding a positive. So we end up with negative 6 as our exponent. So x to the negative 6th. It's all being raised to the power of negative 3. Now again, we apply the power property. When you raise the negative 5 to the power of negative 3, you want to put that in parentheses. And the reason is that that negative sign is inside of the parentheses to begin with. Then we have the power property on the x to the negative 6, so we multiply our exponents and get positive 18. This negative 5 has a negative exponent, so we're going to flip it. So we're not going to change the sign. We're just going to change the sign of the exponent, right? So when we flip it, it becomes 1 over negative 5 raised to the positive third power. And we still have our x to the 18th. Negative 5 times negative 5 times negative 5 is negative 125. So we can write this as 1 over negative 125 x to the 18th. Or we could write it x to the 18th over negative 125. It would be the same thing.
And the answer also be, like, it's basically...
All right, 4e is 15. X to the negative third equals 10 x to the negative 2. All right, so this is an interesting equation. It's one that we haven't seen before because we have an x on both sides. And they're not like terms. X to the negative 3 and x to the negative 2, not like terms. We can't get them together and combine them. So what do? What we do is we divide both sides of this equation either by the x to the negative 3 or the x to the negative 2. And it doesn't matter which one, because no matter which one you do, it's going to work out. So let's just divide by x to the negative 3, and I'll show you how it works out. So of course, those will cancel, leaving us with 15 equals. We can simplify this, right? The 10 remains, and we apply the quotient property to the x to the negative 2 divided by x to the negative 3. Subtracting our exponents, we end up with x to the first. Well, this worked out nicely. This is very simple. All we have to do now is divide both sides by 10. 15 tenths reduces to 3 halves. X to the negative 1 equals 125 x to the negative third. Okay, so we're going to divide both sides of the equation by either x to the negative 1 or x to the negative 3. And as I said before, it doesn't matter which one you decide to do. Let's divide it by x to the negative 3. So over here, those will cancel out. We'll be left with 125. On the left side, we have 200, and then we apply the quotient property again, right? So we subtract our exponents. Negative 1 minus negative 3 is same as adding a positive, so we get 2. So we end up with x squared. So we have a little more work to do. We divide both sides by 200. Those cancel out. X squared equals, you could plug that into your calculator at this point if you wanted. I'm just going to leave it as the fraction. And now I can do one of two things. I can take the square root of both sides, or I can raise both sides to the power of 1/2, because that's the reciprocal of the 2. So either one is fine to do, because they will result in the same answer. 2 times 1/2 with the quotient property leaves me with x to the first, or just x. And then I can plug in the other side into my calculator and get 0.79.